Okay, we need 0.250 molar cobalt 2 chloride, and we need 0.500 liters of it. So how many grams of cobalt chloride do we need? Well, basically what we've got to do is figure out how many moles of cobalt we need and then use the molecular weight to convert that number of moles into grams. How do we figure out how many moles? Well, recall that M, molarity, is moles per liter. So if we take 0.250 moles per liter and multiply it by the 0.500 liters of solution that we need, we'll find out how many moles we need. Right? So the liters will cancel, and we'll end up with an answer in terms of moles, right? So we're going to get 0.125 mole of cobalt chloride. Okay, so how many grams do we need? Well, we just take this 0.125 moles of cobalt 2 chloride and multiply it by the molecular weight of cobalt 2 chloride, which is 129.839 grams per mole. Moles cancel. And we get 16.23 grams. Next problem. We've got 14.4 grams of magnesium nitrate dissolved in 1.20 liters of water. Okay, we take 25 mils or 0.025 liters, right? Convert milliliters to liters by dividing by 1,000. Okay, and we dilute to 175 milliliters or 0.175 liters. What is the final concentration? Well, first of all, we need to figure out what the concentration of our solution is. Once we know that, then we can figure out how many moles were in our little sample and then divide that by the number of liters in our larger sample. That's our path forward. So I already figure out how many moles, what the concentration of our large sample is. Well, we need the molecular weight of magnesium nitrate to determine how many moles of magnesium nitrate we had in our 1.2 liters of solution. So the molecular weight of magnesium nitrate is 148.3 grams per mole. So we can take our 14.4 grams, right, and multiply it by 1 mole for every 148.3 grams. And we'll have moles of magnesium nitrate when we're done. So 14.4 divided by 148.3, and I get 0.09710 mole magnesium nitrate. Okay, so the concentration then of our large solution, our 1.20 liter solution, was our molarity, which is moles per liter, right, is going to be 0.097100 mole divided by 1.20 liters. What's the concentration that we get? we get 0.08092 molarity, or moles per liter. Okay, now we're going to take 25 mils of this. So we need to know how many moles are in that 25 mils. So we'll take our 0.08092 mole per liter and multiply it by our 0.025 liter to find out how many moles we got. So take this number and divide it by 0.025. And now I get that we collected 0.002023 mole in our 25 mil sample. And we're going to dilute this to 0.175 liters. So what's our final solution? Well, it's going to be the molarity of our final solution will be this number of moles divided by 0.175 liters, which will give us 0.01156 mole per liter. Oh, but we want to know the final concentration of the nitrate ion, not magnesium nitrate in general. Recall that there are 2 nitrate ions per every magnesium nitrate molecule, right? So we actually need to double this. So if we multiply it by 2, what do we get? 0.02312 mole per liter.